Hey everyone, and welcome to The Explainer. Today we're talking about a chemical with a pretty epic nickname, sulfuric acid, aka the king of chemicals. So, how exactly does a simple molecule get a title that grand? Well, that's what we're here to find out. Let's get into it. Okay, here's our game plan. We'll start by meeting the king and seeing why it's so important. Then we'll check out how it's made, explore its two totally different personalities, see how it dominates the industrial world, and finally, I'll show you how to spot it in the wild, or, in a lab.
All right, first up, meet the king of chemicals. But really, why? Why this particular molecule? I mean, it's just H2SO4, right? What's the big deal? Let's figure out what makes it so special.
It all boils down to one word: influence. This quote really says it all. Think about it. There's pretty much no other chemical that's used by so many important industries. It's not just an ingredient in things, it's the thing that helps make almost everything. It's a total game changer.
So if it's a king, how does it get its crown? Well, that happens in a process called the contact process. Let's take a look at how this royal acid gets made.
Okay, the whole thing breaks down into four main steps. First, you got to make some sulfur dioxide. Then, and this part is super important, you have to clean it up. After that, you use a little chemistry magic with the catalyst to turn it into sulfur trioxide. And for the grand finale, you absorb that gas to finally make the acid.
All right, so this here is a map of the whole operation. I know, it looks a little intimidating, but don't worry, we're going to walk through it. Just think of it like a journey, where our main ingredient, sulfur, goes through a bunch of different stations to get transformed.
Okay, let's follow the journey. It all starts in the pyrite burners, where we generate our sulfur dioxide. Then it's off to a seriously intense spa day. First, the dust chamber gets rid of dust. The scrubber gives it a wash with water. The drying tower dries it off. And the arsenic purifier, well, it gets rid of any arsenic. Now, why all this cleaning? It's all to protect the most important part, the catalyst in the contact tower. That's where the real magic happens, turning SO2 into SO3. Finally, it heads to the absorption tower, where that gas gets absorbed to make our final product, pure concentrated sulfuric acid.
So to make that key step in the contact tower work perfectly, you need the perfect recipe. It's kind of like baking a cake. You need the conditions to be just right. We're talking a low temperature, around 450 degrees Celsius, which is still pretty hot. A high pressure of 1 to 2 atmospheres, lots and lots of oxygen, and of course the secret ingredient, our amazing catalyst, vanadium pentoxide.
All right, this is where things get really interesting. Sulfuric acid has, well, a split personality. It's like Dr. Jekyll and Mr. Hyde. Depending on how much water is mixed in, it acts like two totally different substances.
So check this out. On the left, you've got dilute sulfuric acid. It's a strong acid, a strong electrolyte. Basically, it's your classic textbook acid. But then look at the right. The concentrated stuff, it's actually a weak acid and a weak electrolyte. Weird, right? But here's the kicker. It's also an incredibly powerful oxidizing agent and dehydrating agent. It's a total flip-flop.
Let's talk about that typical acid face. The dilute version is exactly what you picture when you think acid reaction in science class. You drop in a piece of metal, like magnesium or iron, and fizz. It bubbles and produces hydrogen gas. Simple, classic, predictable stuff.
But the concentrated version? Whoa, it is a completely different animal. It's a monster of a dehydrating agent. That means it's so thirsty for water, it literally rips the H and O atoms right out of other molecules. The most famous and kinda creepy demonstration of this is when you pour it on sugar. It pulls the water out and leaves behind this growing black snake of pure carbon. It's an unforgettable sight.
And that brings us right back to why it's called the king. With all these crazy properties, you can bet it's used everywhere. So let's explore its massive industrial empire.
So take a look at this. The number one use by a long shot is making fertilizers. Without it, we'd have a much harder time growing all the food we eat. But it doesn't stop there. It's crucial for making other chemicals and dyes, for pickling metals, which is just a cool name for cleaning rust off them, for refining the oil that becomes gasoline, and yeah, even for making explosives like TNT. Seriously, the list just goes on and on. That battery in your car that starts the engine, it's in there. Some of the soft fabrics in your clothes, like rayon, it helped make them. The medicines you take, the colorful paints on your walls, yep, it's involved. It even helps make the glass in your house. Once you start looking, you realize this stuff is literally all around us.
All right, let's get into our last section. How to spot the king. This is a super practical one, especially if you're studying chemistry. So how do you prove that sulfuric acid, or at least a sulfate, is in your test tube?
Well, there's a classic telltale test. It's like a royal signature. All you have to do is add a little bit of barium chloride solution. If you've got sulfate ions in there, bam! You'll instantly get this thick white solid that appears out of nowhere. That white stuff is barium sulfate, and it's your dead giveaway. If you see that, you've found your sulfate.
Okay, pop quiz time. Let's see what's stuck. Ready? First question. What's the name of that super important catalyst in the contact process?
The answer is vanadium pentoxide, V2O5. Yes, if you got that, nice job. Just remember, it's the wise advisor in the process, making sure everything happens just right.
Okay, final question. Let's go back to that super dramatic demonstration. What happens when concentrated sulfuric acid gets poured onto sugar?
You got it. It dehydrates it. It rips the water right out, leaving behind a big old black mess of carbon. It's probably the best way to remember just how powerful concentrated sulfuric acid really is.
So there you have it. From the huge industrial plants where it's born to that crazy reaction in a beaker, that is sulfuric acid, truly the king of chemicals. If you found this explainer helpful, please do me a favor and like, share, and subscribe, and definitely don't forget to press that bell icon. Thanks so much for watching.